Now that you've watched the videos on how to factor polynomial equations, we're going to take it one step further and solve polynomial equations by factoring. Write down example number 5. Your number one job before you even start to factor is to get these polynomials in standard form. Remember, that means your degrees need to be in descending order. So I'm going to need to subtract that 18x cubed off of the right side and get it onto the left side. I'm going to put it second because I need that x third to come before the 15x. And you set it equal to 0. This really is nothing new compared to when we solved quadratic equations. So we have this in polynomial standard form, and you get out your factoring flowchart and you say, do I have any greatest common factor between these three terms? 3x is the GCF of this expression, so when I divide that out of all the terms, I'm going to get x to the fourth minus 6x squared plus 5. Now keep factoring because you're not done. Remember, this is called quadratic form, meaning it factors the same way as if it was a quadratic, and so x to the fourth will be broken up into x squared and x squared. What two numbers, when multiplied together, would give me a 5, but when added give me a negative 6? Now, this should really start to look familiar. We're not factored completely yet because hopefully you realize we have a difference of squares pattern going on here. So we need to go one step further. The 3x is prime and the x squared minus 5 is prime, but this x squared minus 1 will become x minus 1, x plus 1, all still set equal to 0. Now that we are factored completely, we need to recall the zero product property. Remember, that says if you have things being multiplied together and you end up with an answer of 0, that one of them had to be 0, or all of them. So you take all your factors and set them equal to 0. And then proceed to solve them all. There are your 5 answers. Now, why did I say 5? Here's one answer, that x equals 0. Another solution, this one, has 2 actually. You have the positive square root of 5 and the negative square root of 5. Here's your 4th solution and your 5th. Remember, back in quadratics, these could also be called intercepts. So if we were graphing this polynomial, these would be the places where your graph crosses the x-axis, the x-intercepts. Another thing I want to point out to help you so that you know you're doing it right, a little guiding principle, is if you notice that this highest degree of this polynomial is 5. So this is a degree 5 polynomial. If you're a degree 5 polynomial, you're going to have 5 solutions. 1, 2, 3, 4, 5. So it's a nice little check even before you begin. We'll do another example together and then I'll set you off to do the guided practice. I have a little typo on this. This is supposed to be 2x to the 5th power. Remember what your first job is to do, and that is to get this in standard polynomial form, meaning that it needs to be in descending power order. I'm going to bring everything over to the left side because you generally do not want a negative leading coefficient. So that will keep my 2 positive. You are going to subtract 12x cubed from both sides to get rid of it, and then add 16x. Your next job is to look for a GCF. Is there one? And what will this quotient be here when you divide everything by 2x? Are you done factoring? This trinomial will factor into the 2 binomials. What factors go in the last terms? Again, the question you're asking it yourself is, what 2 numbers when multiplied give me an 8, but when added give me a negative 6? That's a negative 4 and a negative 2. Are you factored completely is the next question you ask yourself. That answer would be no, because you have the difference of squares pattern here. And so that will break up into x plus 2 and x minus 2. This term is done because 2 is not a perfect square. Now that you've reached being factored completely, you need to use your zero product property and set all of these equal to 0. When you go through and solve them all, you will see that you get x equals 0, x equals negative 2, x equals positive 2, and x equals plus or minus the square root of 2. Now, do you remember how many solutions we were supposed to have? The highest degree tells you that we're supposed to have 5 solutions. Here's 1, 2, 3, and there's 2 more solutions there with the positive and negative root. So you do have 5 solutions, so chances are you might have done it right, at least the process. Pause the video and do the 3 guided practice problems. When you're done, unpause it and come on back. Here are those answers and what they look like. I would appreciate it if you did write these all out using the zero product property. I was just running out of room. Stare at these, make sure you got the same answers and the right number of answers. And again, if you have any questions, we are here for you. Thanks for watching.